Alex, I'm gonna kill you. Yeah, you should be able to hear me. I don't know why you wouldn't be able to. I haven't changed anything from yesterday. Alright, people. We're gonna get started in about 3 minutes. So I want to give everyone a chance to kind of hop on if they'd like to hop on. We're just gonna be going over homework today mostly. Like, there's not really the lesson for today is a lab, and the lab you can do by yourselves. And there is a place where you can like kind of find info if you need it. You can find it on the packets that we gave out before we went on break. That's an option. What do you need to? What do you need remorse for, Kwanzaa? Oh. No, Brian, you can't send pictures of old labs because I can't file them. I can't do anything with it. That's the kind of thing you should have finished before we had Coronacation. Come on. Alright, 2 more minutes, guys, and we'll get started. Hi, Stephanie. Do you even get the homework I sent in the reminder? Yes, Amari, I do get it. Sorry if I don't tell you that I get it. I've just been getting overwhelmed with the messages. So there's like probably about 100 of you texting me at around 12 every day because it's not only the physics kids but also the chem kids. So in case that I put in a 0 in the gradebook when you know that you did it and submitted it on time, just text me and like send me a screenshot of you sending it on time and we're good to go. Okay, we're gonna get started. So this is the homework from last night. I want to go through each problem, make sure that we're all understanding where everything's coming from, and if we kind of need the help, then we can talk about it a little bit. So, what is the gravitational acceleration on a planet where a 65 kilogram person has a weight of 165 newtons on the planet's surface? So, this is asking me for gravitational acceleration. I know that I have a formula that combines gravitational acceleration, weight, which is the same thing as Fg. Oh, back at it again with terrible handwriting. And we have a mass. Ooh. We have a mass. So I need to think about the formula that combines gravitational acceleration with mass and force, and that is F equals ma. And I'm being asked to solve for acceleration, so I do 165 is equal to 60 a, and a in this case is equal to 2.75 meters per second squared. Shouldn't be blowing any minds there. Moving on to number 2. Which diagram represents the gravitational forces Fg between a satellite S and Earth? So we've got these diagrams, and I understand where the confusion came from for a lot of you, because I had said that gravitational field lines should only really point towards the center of the object, and they are actually in this case, because remember, gravitational field lines represent how objects around that object would interact with them. And in the case of both 1 and 3, they're showing us the object, in this case this planet or whatever this is, a spaceship or whatever, is pointing towards Earth. It's being attracted by Earth. And so in both cases, this is the correct line for a gravitational field line. But this is not asking us just for gravitational field line, it's asking us for all the gravitational forces. And I know that if there's a force in one direction, like if Earth is attracting this with a force of Fg, this object also has to be attracting Earth with a force of Fg back. They got to be equal and opposite. And the only drawing that shows us an equal and opposite force is drawing number 3. So drawing number 3 is going to be the correct answer here. Number 1 is incorrect because it doesn't show an Fg pointing back in the direction of the other Fg. There's no equal and opposite forces here. Number 2, the forces should be pointing at each other, not away from each other. These don't even show the two objects interacting, which is not true. And number 4 is the same problem as number 1, just in reverse, where the forces don't point in each other's directions, like in opposite directions, and towards each other, and everything is pointing away from Earth. So no bueno. Number 3. Which of the options below can be used synonymously? So we talked a lot about this yesterday. We talked about the fact that even though we were calling it a gravitational field strength, it really means the same thing as acceleration, because I know that the formula for gravitational field strength is G equals Fg over m, which I can rewrite as Fg equals mg. And I know that the formula for acceleration is F equals ma, g. So g and ag are the exact same thing. So we can use those interchangeably. Number 4 was tougher, and I think we need to explain something. No, not quiz today, Natalie. Today's just a practice. It's a practice quiz for what I'm gonna give you an actual quiz on Monday. Number 4. So number 4 on the diagram, and actually I'm gonna include number 5 here too, because it's all based on the same picture. So number 4 tells us an electron is placed between parallel plates that are oppositely charged, as shown below. So we have 2 plates, and I drew in an electron in the center of them. Now here's the thing, and this is what you need to keep in mind. Electrical fields are only dependent, like the creation of the electrical field is only dependent on the plates. That's all that really matters for creating this field. The electron exists in that space, yes, but we don't really care about, the electron's not going to affect the field is going to affect the electron. So we kind of ignore the electron for now. It's not going to be an important factor in how we make this field. Because again, the only thing that matters when creating the fields are the plates. Now, we've got the 2 plates, and I know that in any kind of situation, my charges should be pointing towards the negative and away from the positive. So I know even though it looks funky, again, we're ignoring that electron there. It is not part of me drawing in that electrical field, because the electrical field is only based on those parallel plates. Now, number 5 gets on the idea of this electron, what it's really doing in there. The magnitude of the electric field strength between the plates is 8 times 10 to the negative 2 coulombs. What is the magnitude of the electric force on the electron? So, a lot of you were struggling with this a little bit. Electric field strength should immediately tell you E equals Fe over Q. And it tells you that the electric field strength is 8 times 10 to the negative 2 coulombs. That is the value for E. What is the magnitude of the electric force? So you're trying to solve for Fe. You don't know it. Now here's the problem. A lot of you kind of got stuck here because you weren't really sure about what to do with Q. But you know the charge of an electron. You know the Q of an electron. This is the elementary charge. The elementary charge. And remember that the elementary charge is a value that you can find on your reference table. This is the 1.6 times 10 to the negative 19 coulombs. And this is always the charge for an electron. Yes, Mahogany, that would be incorrect. If you drew an arrow from the positive place to that electron, the other... Yes, because remember, the electric field is only dependent on the plates or the charges that are already in there. It's not dependent on like a charge you put into the field. The charge that you put into the field is going to be affected by the field. It's not going to change the field in any significant way. So again, that field is just dependent on the plates and not dependent on that charge in the middle. So when we solve this out, now we have a Q, we have an E. That's going to be 8E negative 2. Oh my god, that somehow just got worse and worse. 8E negative 2 is equal to Fe over... What if I drew arrows coming from both the positive and the negative side? You shouldn't have, because, well, how did you draw it from the negative side? Did you, if you drew like something like, you'd have to have drawn something like this. You'd have to have drawn, well, when we care about parallel plates, we really only care about the field that's in the middle. Simple as that. We really only care about the field that's in the middle. But if you wanted to draw like what it would have looked like on the outside, it would have looked something like this, right? Because we would have had charges being attracted to the negative and charges being pushed away from the positive. But again, this was not like a requirement. I really only care about that field that's created in the middle. I'm actually going to erase this because I don't really care much about it. Okay. Fe over 1.6 E negative 19. And the Fe that you get here, also one thing to keep in mind, this should be negative 1.6 because again, the charge of an electron is a negative value. So it should have been negative 1.6 E negative 19 coulombs. And that will end up equaling for Fe, once you multiply those two values together, you end up getting that Fe is equal to negative 1.2, I think it's like negative 1.28. Negative 1.2 times 10 to the negative 20 coulombs. Now, I know a lot of you have asked me before, when does the sign matter? It matters for questions like these. Because negative is directed to positive, like positive is to negative. Because negative is directed to positive, like positive is to negative. What question are you referring to, Kwanzaa? What is not negative, Natalie? No, the charge of an electron is never positive. Remember that the charge of an electron is always negative. Now, the value of the charge is 1.6 times 10 to the negative 19 coulombs. But an electron is the negative version of that. A proton is the positive version, right? So, I'm going to write this in. A proton is equal to positive 1.6 times 10 to the negative 19 coulombs. And an electron is equal to negative 1.6 times 10 to the negative 19 coulombs. Yeah, you should only be drawing the arrows from negative to positive. From positive to negative. Remember that we're attracting negative charges, repelling by positive charges. Because electric fields are always dependent on those small positive test charges within the field, right? So we always draw arrows thinking about, okay, what would happen if I had a small positive test charge here, one here, one here, one here, one here? And that's always going to be pushed away from positive and pushed towards negative. If that doesn't really make a lot of sense, that's okay. you have to just memorize that you always draw arrows pointing towards the negative and away from the positive. Mahogany, yes, the charge depends on if it's negative or positive. If it's an electron, in this case, the magnitude of the electric force is going to be negative. If it's a proton, it would be positive. And remember that we use different formulas for this kind of problems too, right? Like, we have another way to calculate electric force. The other way to calculate electric force is Fe is equal to K Q1 Q2 over R squared. So really, the best advice I can give you is just be consistent with putting in your signs, and you're going to be totally fine when it comes to the answer. Okay, moving forward. Remember that if you didn't get a chance to write down all of that, you're able to play it back really easily. All right, numbers 6 and 7. So number 6, Julia weighs 400 newtons on the surface of Earth. Also, just so y'all know, you can call me in the middle of the stream. That's totally fine. If you have a question that like I'm not really answering or getting at, that's totally fine. So you have to just make sure that you are like just calling in. That's totally fine. I'm totally cool with that. Okay, so number 6. Julia weighs 400 newtons on the surface of Earth and would weigh 1,000 newtons on the surface of Jupiter. What is the magnitude of the gravitational field strength on the surface of Jupiter that Julia experiences? So I see gravitational field strength. That is telling me that I have to eventually use G is equal to Fg over m. I am also given a value of 400 newtons on Earth. That is her Fg on Earth. But I'm trying to solve for her G on Jupiter. So all of these numbers for this formula have to be Jupiter values. So I know that a lot of you immediately, what you might want to do is just put in the 400 for the Fg, and that would not be correct. Or the 400 for the mass, that would not be correct. But we can use that Fg to solve for the mass. So if I know that the Fg on Earth, if I know that the weight on Earth is 400 newtons, and I know that Fg is equal to ma, and again, all of these calculations are happening based on Earth numbers. I know then that her Fg is going to be 400. I know her acceleration is going to be 9.81 because that's what it's always been on Earth. And I can solve for her mass. And her mass in this case is going to be 40.8 kilograms. These cooking videos, I don't understand what that means, Amber. So it does depend if it's positive or negative. Yes, Brian. Like, remember when I said that, like, most of these questions, they don't even give you a sign, so it doesn't really matter? Well, that question, it really did matter, so you have to be careful. Okay, so m is equal to 40.8 kilograms. Now, moving forward, we've got the second step, right? Because we have a mass now. We have, we have a mass. We have an Fg on Jupiter. So then we can use that as the second step in our setup. G is equal to Fg over m, which is equal to 1,000 over 40.8, and that is equal to my answer, which is 24.5. 24.5 meters per second squared. And that is my answer for the gravitational field strength. Oh, sorry. It says meters per second squared. It could also be newtons per kilogram, so it could be interchangeable. And finally, number 7, the gravitational forces differ from the electrostatic forces, and that gravitational forces are attractive only. Remember that. That's the big difference between gravitational forces and electrostatic. Electrostatic never pushes away. It always attracts towards. That's pretty much it for today, guys. I'm going to wait a couple minutes, see if anyone wants to ask a question, check something in. You divided 1,000 by 400? Yeah, so big mistake there, because that's dividing 1,000, which is an Fg, by 400, which is another Fg. Doesn't help. That's it, Mahogany. But we were only going over homework today. The rest of the homework for Monday is the lab. And there's also like a practice quiz, but I want you to try that by yourself. Nope. we're just doing practice. We won't be learning something new every day. How we're gonna schedule it is we're gonna basically do like 1 day of new stuff, 1 day of review, 1 day of new stuff, 1 day of review to get you a chance to really practice it. Dooley, I have not yet found out anything about the regions. As soon as I know and I'm allowed to tell you, you will know. I promise you that. Yeah, so the lab is posted. You have to go on a website to do it. It's FET. We've played with FET before. Um, I'm not saying my phone number on stream, Alex. You can check Google Classroom to see it. So there's a FET simulation for your lab that's due on Monday. The quiz, there's a practice quiz up. That is your another piece of homework for the weekend, and that is just going to be practice to get you ready for your actual quiz, which is on Monday. So your quiz will be on Monday. I'll assign it at 4. You'll have until the next day to finish it. But the homework due Monday is both your lab and the practice quiz. So it's 2 things. Also, y'all really need to be good about due dates. Like 12 p.m. means 12 p.m. It doesn't mean 12:04. It doesn't mean 12:11. It means 12 p.m. All right. I'm going to end things now. If you have questions, please check Google Classroom or text me, and I will get back to you as soon as I can.